This is Advent of Code 2020, day 23. The puzzle is called Crab Cups. In the previous day's challenge, we were floating along on a raft, and a crab made its way onto the raft as well. And we challenged that crab to a couple of games of cards. And now the crab is turning the tables on us and wants to challenge us to a game. This time, a game of cups where the cups have different labels on them. The crab is going to do a bunch of moves with a sort of prescriptive set of instructions, and we have to be able to predict how those cups are going to end up. So the crab will do 100 moves, and the way that it does a move is it has a current cup. The crab has 5 cups labeled 3, 2, 4, 1, and 5 in this instance. And so the first cup will be that 3. The crab will then pick up the 3 cups immediately to the right or clockwise of that current cup. So the crab will pick up 2, 4, and 1. And then the crab will select a destination cup based on what remains. So 2, 4, and 1 have been picked up. What remains is 3 and 5. The destination cup will be the cup labeled 1 minus the current cup. So we would look for 2. It's not there, so then we'd look for 1. It's not there. So then we'd circle back around and find the highest cup, at which point we'd find 5. So then 5 would become the destination cup. And the crab would then place the cups it just picked up so that they're immediately clockwise of the destination cup. So it would now be 3, then 5, and then 2, 4, and 1 in that same order would come after 5. And now the current cup would advance 1 to the right or 1 clockwise. So now the 5, which is now after the 3, would become the next current cup. And that would be the first move, and now the crab would follow these same instructions for the next move. Crab will do that 100 times, and the cups will get shuffled quite a bit, and we need to be able to predict or deterministically figure out what those ordering of cups is going to be. So we get a little bit of an example here with this series of 9 or 10 cups, 9 cups, I guess, and but for only 10 moves. So we get down here, the 10th move happens, C5 is the current, 7, 4, 1 get pulled up, the destination becomes 3 because it's the next one that's less than 5, and so then these get placed that's the destination, so then 7, 4, 1 get placed here, and that's the final turn. So then given this final arrangement of cups, we would find wherever cup 1 is, we'd find all of the cups after that going clockwise. You can imagine this is like a circle or a linked list, like a circular linked list where 6 then wraps around and points to 5 because these things are arranged in a circle. So then we'd find 9, 2, 6, 5, 8, 3, 7, 4. 9, 2, 6, 5, 8, 3, 7, 4. That would be the answer if we did 10 rounds. If we did 100 moves, then we'd end up like this. And so that's what we're going to have to do, but for this set of input. So I'm going to copy that puzzle input and jump over to here where a little bit of the work already in place. So I've got a linked list item class, and what that represents is, say we've got an item like 3. It then points to either nil or another item of some value, and so then that item could then point to nil or some other item, and so on and so forth. So the linked list item represents just a single instance of this. We initialize it by giving it an item, which is a value or an integer, and then a next item, which ought to be another linked list item. We've got an inject function, which can take some chain of items and inject that in between this current item and the next item. So I can explain a little bit more how that works in a bit. We also have a last item function or method, which says, okay, here's a current item. Let's find the last item in this chain. And in the event that this chain forms a circle, we would have a little bit of, have a sort of a termination case where if you equal yourself, then we break out of this loop and whatever item was before yourself is then the last one. So if we start with 3 and it goes 4, 5, 2, 1, and then points to 3 again, we'd go 4, 5, 2, 1. See that the next one is 3, we terminate, and 1 would be our last item. And so inject is able to use that to say, hey, here's our first item, which is the current item getting passed in. Let's find the last thing in that chain using last item. And then we can stick the first and last item between the current item of this instance of the linked list item and its next. So if we had 3 and it pointed to 4 and that pointed to 1 and then that wrapped back around, and you wanted, and let's say we have 4 and we say, you know, I want to say 4 dot inject 2, where 2 is something that points to 5 and points to nil. Well, then we'd be able to just say, okay, we've got 3 pointing to 4. 4 is our current item, this instance, and we want its next item to point to first, which is 2. So we do that, it would point to 2, and we'd have some chain of things, which eventually ends in the last item of 5. And then 5 would be updated to point to the next item, which is 3, 4, 1. And then that then wraps back around to the 3. So you can see we started out with 3, 4, 1, back around to 3. We're able to inject 2 and 5 into the middle of this using this inject method. So those are 2 pieces that I imagine we would need in order for this whole cup game to work. And then the outer class that makes use of the linked list item is the circular linked list. And the bulk of the logic here is in initializing it. So it's given a list of items, a list of integers in our case, and it's going to grab the first one and then destructure the rest into a list. It's going to create a linked list item for the first that doesn't point to anything, just points to nil. And then it's going to set that first to be the current. And now it's going to go through these, the rest of these, popping off the next item and keeping the rest after that in a destructured array. And it's just going to keep going until it hits nil, until it gets to the end of rest. And so each time it's going to create a new linked list item that points to nil. Then it's going to inject that new linked list item after the current. So if we started off with 1 and our next item is 2, 1 was going to be pointing to nil, but now it's going to be pointing to 2, and then 2 will continue to point to nil. We'll then continue to destructure next and rest until, again, we get to next item being nil. So they'll just keep appending items on to the end of this chain. Once we've exhausted all the items in our incoming items list, then we exit the until, and we will update the current next item, which at this point will be the last item on the list. We'll have it we'll have its next item point to first, making it circular. And then we'll update current to be the first so that we can play the game from there. Let's see. We've got a take function here, which will just grab n items off the off of the list. So it'll say, hey, whatever the current is, give me the next item. We'll take that, and then we'll take n-1 items after that. We'll just rip those out and we'll update current so that it fills in the gap, and we'll return this first item, which will be this sub chain that we ripped out. And then we've got a couple utilities here, one to turn the thing into an array and another to turn that into a string so we can print it out and see what this looks like. So is this our starting input, or, oops, I did some copy and paste. Let me grab this again. Yeah, 326, 478. Okay, great. So we've already got that here. We create a list. We're eventually going to have some result that we get to and print that out, but let's just see if everything's getting initialized like we'd like. So we hit our breakpoint. Let's look at the list. As you can see, we've created this recursive data structure that has a bunch of nesting of items and then eventually points back to itself again as the first item, and that's just going to keep displaying as a loop. So we have that, and if we were to say list.toS, we'd see that it prints out with 3 and then the rest of the things pointing. If we were to say list.first, okay, we didn't expose that, so that's good to know. I'd like to be able to reference the first and the current and all that, so I'll create some ratters or readers. First, current, and I think that'll do. Did I get this wrong? What did I guess I would have expected some syntax highlighting there, but maybe that's fine. Okay, let's run this again. Oh, I pluralized it. Whoops. Okay. So run that again. Say list.first is going to be just this first item, I guess. Yeah, the 3. So then we can say list.first.item. That'll tell us it's 3. Say list.first.next item. That would give us the next item, which is 2. So yeah, we've got this data structure here. We're able to access the things in it. We could say list.first.last item, and I think we would get this 8 here. Yeah, we sure do. Okay. That's great. I like how that's working for us. So I guess to play this game now, we need to encode the rules that this crab has set forth for the game. So we take note of the current item, then we pick up 3 cups after the current item, then we find the next cup after current that is less than the value of current. I don't know if I've got that rule quite right. Let's take another look. The crab selects a destination cup. The cup with a label equal to the current crab's cup label -1. If this would select one of the cups that was just picked up, crab will keep subtracting 1 until it finds a cup that wasn't just picked up. Okay. So we'll just subtract 1, see if that's in the remaining set. If it's not, then we can keep going. And then eventually, if we get to 0, then we would cycle back around and find just the max value. Okay. If you can't find it, keep subtracting until you find it or reach 0. If you still haven't found it, then find the max cup that isn't the current, I guess. Yeah, you never want to find the current cup. Okay. I don't think. On any cups label. So maybe you would. Okay, well that simplifies things. Could even be the current cup, I guess. That could happen. Okay. Although probably not because of the way it's decreasing the value. Yeah. Okay. Find the next cup as the. Okay, so this is the destination cup. Then we want to inject the picked up cups after the destination, and then update current to be the current's next item. And then we keep going and we do that 100 times. So we'll say 100 times do. We're going to do all of this. All right. So the current will be list.current. Then we pick up 3 cups. So we'll say picked up cups gets current dot take 3. Find the next cup after the current that is less than. Okay. So let's start here. Current value gets current dot item. And then I guess we want to find, we're trying to find a destination. So we'll start out with nil and we'll say current value down to 1. Do. So we'll, I guess, basically look at the list and say, does list 2a, I believe 2a creates the list items themselves. So if we want to pull the actual integer values off, or no, that's good. So yeah, we'll start there. So we'll say list to a, and we'll say find where list item equals val. That, and so if, I guess we'll break if destination, unless destination is nil. If it's nil, then we got to keep looking. If we eventually get down to 1 and it's still nil, then that's where this next piece comes up. So we will say if destination is still nil, then give us the list dot to a dot max, and so we'll get list item 1, list item 2. Do a comparison here of the items using this little shuttle thing. List item 2 dot item. So that'll give us the max, and that will become our destination. All right. So this is the destination cup. Okay. Then we want to inject the picked up cups after the destination. So let's say destination.inject picked up cups. And then we will, oops, gotta close that. And then we will update the current. So current gets, list.current gets updated to be current.next item. Okay, that'll run 100 times and we should have a result. And I guess the result is we need to then find the number 1 item, and then we need to find everything after that. So yeah, let's see. Let's say final items gets list.2a, and while final items dot first dot item is not equal to 1, we'll say final items dot rotate. So that's just going to keep spinning the list until we keep spinning this final items array until 1 gets placed at the beginning. And then we can say 1 rest gets final items. And from there, say rest.map. Yeah, map. List items, we get the integer value off. And then we'll join it like that. To S even, just to be sure. That'll be our result. And we'll spit that out. So does it run? Not quite. Take for linked list item. Okay, take 3. Sure, so this needs to be list.take3, which plays off of whatever the current is. I think that's fine. Okay. Now it's running. It's taking a little while to run, which makes me think that I might be in a loop. Yeah, it shouldn't take this long, so I'm going to bail out of it. Wonder why that could have happened. What did it exit out of here? We interrupted on last item 33. It was doing an inject. Last item 33. Okay. Sure, and then last item gets called by inject. So were we in some sort of infinite loop, perhaps? I thought that had been well accounted for. Yeah, I mean, this is only ever gonna grab, you know, n-3 items. Yeah, this turns the list into an array and grabs the max off of it. While final item stop first. Dot item is not equal to 1 and rotate. I like the looks of this. What if we jump over here, we start with these instead. And we paste that in here. So we use this as a starting point instead. And then we run it 10 times. I wonder if that gets anywhere. Okay, it doesn't. But what we can do then to debug this is to start, I guess, printing out list.toS. And then when we pick up some cups, we can say, how is it printing them out? It's picked up, yeah, cups, pick up destination. I like that. Okay. All right, move one. We'll really try and emulate this whole thing. I plus 1. Then we'll print out, what is it, cups. Yeah, then pick up, then destination. And in this case, how do we want to print this out? We'll say picked up cups dot map No, that's not going to work, but I do wonder if 2S could be moved to maybe some version of 2S could be put on this thing. So we'll say I guess it could work a lot like last item, but instead of building up, or instead of finding the last, it appends things. Yeah, maybe 2A belongs in here too. Maybe putting those on circular linked list wasn't the best place to put them. So we'll say that our array gets item, and then while array dot last dot next item is not equal to item, and it's self. While it's not equal to self, and while the next item is at nil, then we should add the last item's next item to the array, and then we eventually spit it out. Okay. I think that'll work. So then 2S can say, yeah, give me the first. Okay. I think that'll work the same. Cool. So in that case, I can say picked up cups dot 2S. Oh, I guess the only thing I want to do differently here is not not wrap this first thing in the, do they wrap them? No. Okay. So we'll not wrap that first thing in there. This little thing can just be 2a.map, join it all up, get rid of that. Prefer 2s over string interpolation. Not sure why it's saying that, but that's okay. Okay, so we print out the picked up cups, then we should print out the destination. Is that what they call that? Destination, and then just the item like that. Now we should have something to compare as we run this. That's good to know. It's just getting stuck right away. Okay. That's really helpful. So it immediately goes into times block 2. Oh, it's getting stuck in 2s on the 2a. Oh, that's interesting. Okay. So this picked up cups 2s is in a loop, I guess. Let's see. It calls 2a. Sure. It then maps and joins those. So 2a is getting stuck, huh? Probably because this should be an OR. Is that true? While, no, that's an AND because this is when we break out. While we're not ourself and the next item isn't nil, while both of those things are true, then add something to the array and keep going. So the array is going to keep updating. It's going to keep having a new last item. Last next item. I like the way this looks. I'm not sure what why it's getting looped here. I wonder if I can get ahead of this and see what's going on. So we'll pry in here. We'll run it. Great. List.first. List.first.2a. Okay, 2s. That seems fine to me. Okay. List.2s. Again, that seems fine to me. List.2a. Sure. And yet we're still getting hung up right there. So this is after we've done a take. Could there be something going on with that take? Because the sequence of events is we take 3 off of the list. Yeah, I'm very curious to see if take's doing what we think it is. So we'll pry back in here. We've got our list 2s. Say list.take. Picked up gets list.take 3. Okay, so then what's list.2s now? Oops. Yeah, that seems right. Right, 3. These are pulled off. 2, 5, 4, 6, 7. Okay, and then what's picked up that 2s? Oh. So that's the issue. Do we need to have take nil out the last item? Yeah. Last next item gets nil. Okay. I think that's where we were getting caught up. Otherwise it was, we sort of had this list that was like self-referencing, and so we were never, right, we'd take out 3 items, but that list of 3 items would reference the original circle of cups, and so then we were never able to identify the loop because of that. There, that should clear things up. Let's put that back. Let's go 100 times binding. Okay, good. I'm feeling confident, so I'm just going to run this again. Current. Did you mean current? Oh, sure. Because we made current just an adder reader instead of a adder accessor. Oh, it went for a while and now it's stuck after move 100. Okay, well, that's more promising. What happened after move 100? After move 100, it exits out of here, and then we do the 2A. So we're stuck in this thing, I guess. Let's give that a try then. Pry into there. Find all items. Okay, and so then find items is an array, right? So rotate, rotate, rotate. Huh. I guess that's not doing what I thought it would do. Am I misunderstanding how rotate works? Oh, it's not updating stuff. Okay. I see. I need to use the destructive version of rotate. Here we go. And we've got an answer here. 947. Yeah, 9473265. Okay. Is that our answer here? It's too high. Okay. Did I misread the... What are the labels on the cups after cup 1? Simulate 100 moves. Did I run it against the correct input? Three, 2, 6, 5, 1, 9, 4, 7, 8. 100 times, yeah. Oops. Did I use the right starting point? Is the... Yeah, immediately clockwise of the current cup, okay. Yeah, before the crab starts, it will designate the first cup in your list as the current cup. Yeah, just like we did, okay. So then, yeah, right, each number except 1 should appear in there. Let's see, I guess if we run this and we can maybe just scroll up and see how some of these played. Move 1, we have 3, so we get grab 2, 6, 5. Why did we pick 3 as the destination? That's the problem. All right, let's fix that. Right here, current value down to 1. Nope, it's current value minus 1 down to 1. There we go, that's a different number and a bit lower than the one we had before. And I have a feeling it's the gold star number. All right. Well, that was part 1, and stick around for the next video because we'll take a look at part 2. Thanks for watching.